Welcome to this video. In this video, we are going to see the elementary data link protocols. To know the need of these protocols, we need to know the function of data link layer, which in effect is to make the physical layer look like wire, a devoted channel, which is free of error and with unlimited capacity to the network layer. In effect, the data link layer has to handle the errors which may be there in the physical layer, and it has also to tackle the flow control where the receiver may not be able to receive the data which is being transmitted by the sender. And to implement this, we have seen that the data link layer basically makes frames out of those packets which are received from the network layer. And to implement these uh, frame formation, error control, and flow control, these are the protocols which we'll be seeing one by one. So their complexity will be going on gradually increasing. The first is Utopian Simplex protocol. Next is Simplex stop and wait protocol, which will be seen in two versions, one with error free channel and one when the channel is noisy or there may be some errors. A third version, which is called as a positive acknowledgement with a retransmission protocol, will also be seen at the end. So to begin, we will first see how these three layers, the network, data link layer, and the physical layers, may be implemented in a system. So in the most general case, if you see this diagram, uh, a part of link layer, that is the data link layer, as well as the physical layer, are mostly implemented onto the network interface card, NIC we call it. That's a hardware. Where as the network layer as well as the data link layer may be implemented as separate processes in the operating system, where the data link layer mostly acts as a device driver. Alternatively, these three layers may be implemented onto a separate hardware called as network hardware accelerator, network accelerator. So there may be any implementation of that. There may be implemented in hardware, or they may be implemented as three independent processes. It is always better to understand them as three independent processes, which emphasizes they are three independent layers. So with that as prologue, let us go to understand the elementary data link protocols. Here we'll assume something, some uh, things will be assumed. Here A and B are the two machines which want to communicate. A is the sender and B is the receiver. A wants to send a long stream of data to machine B. A has got sufficient data to transmit, and that has to be transmitted to machine B. It uses a reliable connection oriented service. That means that there will not be any connection problems afterwards. Once the connection has been established, there may not be some errors. That communication will be reliable. Now it assumes to have infinite supply of data which is already available, ready to send. It does not have to wait for data to be produced. Machine A and B themselves do not ever crash. The data link layer treats the data as sets of pure data. So every bit is to be delivered to the destination's network layer. So these are the assumptions which are made first, and based on that we'll be seeing the next protocols. So we already have seen that basically to implement all those functionalities, data link layer first does what is called as framing, where whatever the packets which are received from the network layer, they'll be encapsulated into the frame. by appending the header and the trailer to the packet. So this is the packet received from the sending network layer, and to that packet, header and trailer will be attached. So effectively this becomes the overall frame to be transmitted, which will be received by the physical layer and then the data link layer, and out of which only the payload part will be sent as packet to the network layer. Where the error correction, first error detection, then the correction may be required to be done. In that case, or in every case, every situation, every instance of packet, the frame formation, the control information is added to the header, and the checksum of the frame is added to the trailer. We also seen this in the error detection and correction previously. And after that, the frame is transmitted to the receiver. Here we'll assume some library procedures to understand how these protocols are implemented. The first is to physical layer. This is used to send the frame to the physical layer. To accept the frame from the physical layer, from underscore physical underscore layer. Wait for event. Now all these things will be seen better in the next slide. At the receiving end, the data is being received and the checksum is being computed by the data link layer at the receiver's machine. There may be two possibilities. The frame is received with error, or that is received without any error. In the first case, when there is one error, the event that is possible is checksum underscore err, checksum error is there. And if it is received undamaged, that is without any errors, the event is simply frame arrival. That means the frame has been arrived without any errors. So we will assume we will understand the data types defined, some variables which are required for the data link protocol implementation. The first we define max underscore pkt, maximum packet size, as 1024. Next we define a boolean data type which can have only two values, obviously false and true. Next, then we define a sequence number which can be of type unsigned integer, which will be used to sequence the frames being sent and received. Next is a packet structure is being defined, which can have an array of unsigned character type. Next we are defining a frame kind. What type of frame that will be? There may be a frame containing simple data. There may be a frame for acknowledgement, and there may be a frame, we'll see, there can be a negative acknowledgement as well. So these are the three types of frames being defined here with that enumeration. Lastly, we define a data structure for a frame, which will consist of the things like what kind of frame that it is. Next is what is the sequence number, what is the acknowledgement number, and actual payload part, that is the packet type info. Next we are going to see the library procedures. Let me iterate that. We are simply seeing the signatures of these functions, how they are called. We are not going to see what is their definition, how they are implemented. We are not at all interested into that. We'll simply assume that they work out of the box. So their actual definitions are given in protocol.h. We are not concerned with that. So the first is wait for event. The data link layer at the sender and the receiver, they'll be first waiting for some event. The event may be arrival of a packet at the sender's data link layer, and the event may be, for example, arrival of a frame at the receiver's data link layer. So next is void from network layer, packet pointer p. So go and fetch a packet from the network layer at the sender's data link layer. That may be possible. So it is going to accept a packet from the network layer, and that will be stored into packet pointer P. Now the whatever the at the receiver's data link layer, whatever the packet that has been composed out of the frame received, that has to be delivered to the network layer. So void to underscore network underscore layer and packet pointer P. So here the data link layer is supposed to give that packet to the network layer. Next, at the sender's layer, once again, from physical, sorry, this is from underscore physical layer frame uh, pointers R. That means get an inbound frame from the physical layer and copy it to R. Once again, that is the receiver's data link layer, which is going to get from physical layer a frame in R, frame type R. Next, pass the frame to the physical layer for transmission. This is the sender's function. The data link layer at the sender will be implementing or will be calling this function. The to underscore physical underscore layer. Whatever the frame composed out of the packet received, that will be first stored into S and then it will be transmitted to the physical layer with to underscore physical underscore layer. Now we know that the data link layer at the sender and the receiver, they must uh, have some kind of way through which the sender's data link layer knows that the transmitted frame has been received, and for that a feedback mechanism may be implemented. And to implement that feedback, there is an acknowledgement frame transmitted from receiver back to the sender. So that acknowledgement frame must be received within some time frame, and to indicate that time frame, we are starting a timer. So start underscore timer with given the corresponding sequence number for a particular frame. So a timer will be started for a frame having sequence number. Consequently, when the acknowledgement is received, we need to stop this timer. If the acknowledgement is received before the timer elapses, we need to stop the timer explicitly. So stop the clock and disable the timeout event. Here start the clock and enable the timeout event. Next, start an auxiliary timer and enable the acknowledgement timeout event. For the acknowledgement, there may be one timer started, start underscore acknowledgement underscore timer. So this is the timer once again for the frame being transmitted. Stop the auxiliary timer and disable the acknowledgement timeout event. Once again, these are the timers which are there for the acknowledgement basically. So we have seen that the network layer may be having packets to transmit, or that may not be having the packets to transmit. And there we have also seen that whenever it has got sufficient number of packets to transmit, the receiver's network layer may not be, or receiver's machine may not be that fast to accept with that speed. That's why the flow control mechanism rather sometimes disable the sender from sending packets or data, and that's how it is sometimes allowed or not allowed to send. So enable network layer basically allows the network layer at the sending machine to send packets, and disable network layer basically forbids the network layer from sending the packets. So the last is one macro defined, which is going to circularly increment one variable k from 0 to some max underscore sequence. For example, in this case, increment k is the macro, which basically checks whether k is less than max underscore sequence, that may be anything which is previously defined. Here we are already defined, that may be defined, for example, for 5, 7, or whatever the value there it is. So if k is less than that max underscore sequence, k will be incremented by 1. Otherwise, if it has already reached max underscore sequence, it will be set back to reset to 0. So that's a circular increment of k from 0 to max sequence. Now the first protocol is called as the Utopian Simplex protocol. Now this is the simplex, or the most simplest of all, because of the assumptions. First, it will transmit the data in only one direction, right from sender to receiver. There is no data transfer from back from receiver to sender. The second assumption is that the communication channel is assumed to be error free. And the third assumption here is the receiver is assumed to be able to process all the input infinitely quickly. So there is no flow control, there is no error control required at the data link layer. And that's why the sender, as it has got unlimited capacity and the channel is also error free, simply pumps out the data into an infinite loop as fast as it can. So with that as assumptions, we will define some variables for this protocol. Here we are defining only one event type is possible, which is arrival of a frame. So with that enumeration, we are using frame arrival, that will be having value 0 because of this enum, and the variable for that is event type. So event type is the variable that can only have one single value, frame underscore arrival. Now we are including that protocol.h, that previous all functions and variables that you have seen so far can be available here. So this is the sender's implementation. First we are defining a frame S, that's a buffer to store a frame, and a buffer to store a packet arriving from the network layer. So as we have just seen, in an infinite loop, the sender does the following. It goes to the network layer, accepts a packet in a buffer, and then forms a frame out of that packet. So the frame is S. So S has got multiple fields that you have seen previously. The info part of that will be filled with the packet payload, that is the buffer, as we have just taken it from the network layer. And the same thing is given, that the packet, that the frame is given to the physical layer for the transmission to the receiver. So 2 underscore physical layer will be called with the S, which is nothing but the frame. And this all is done in an infinite while loop. At the receiver, it has got a variable to store the incoming frame, and it is also waiting for the only type of event, which is the frame arrival. Rather, there is no such need of that, because the only event possible, and that is occurring on and on. Now once again, in an infinite loop, that is waiting for an event, which is obviously the frame arrival. There cannot be an event which is a garbled frame or a missed frame or a lost frame. Only always the frame is arriving intact. So whenever such an event occurs, it goes, the data link layer will go to the physical layer to accept the frame into a variable R, and whatever the frame is received, the header and trailer of that will be discarded, and the payload part of that r.info, that is the packet buffer, that will be transmitted to the network layer as a packet. So as we have seen, based on the previous assumptions, it assumes that it has got unlimited capacity, the network, the communication channel is never going to induce any errors, so no flow control, no error control is required. It is done here. which is not practical. Most of the time the channel may be having some errors and the receiver may be having some capacity. That's why the flow control and error control are required. So this basically resembles a connection-less service that relies on the higher layers to solve those problems, for example the error control and the flow control. So we'll now see a next version of this protocol for a noisy channel, where we'll now assume that the channel may give some error. So protocol 2, that is stop and wait, it provides a one directional flow of data from sender to receiver. Once again the data is from sender to receiver. Here the communication channel is once again assumed to be error free, but this time we are simply implementing that to be having a flow control, means the receiver is assumed to be having some capacity, a finite processing speed, and that's why it simply cannot accept all the way when the sender is transmitting the data, and that's why the sender is needed to care about the speed of the receiver. So that's why the corresponding data structure here is the, as we have seen previously, event type, that is the only possibility is the frame arrival. Next when frame is defined with S, packet is defined with buffer, and event is the event type. Now once again in an infinite loop, the sender's data link layer goes to the network layer, accept that packet into a buffer, and the frame's info part is filled with the buffer, and that frame is sent to the physical layer. And now as it simply cannot go to the network layer directly before getting some acknowledgement from the receiver that it can go and send the next frame, that's why it has to wait for event, and this event is one receipt of a frame from the receiver. Here the data will not be sent back from receiver to sender, but there can be a frame which is acting as an acknowledgement for the received frame. So wait for event, that is the new thing which is added here. So once an acknowledgement frame is received from the receiver, this wait for event function will will conclude, and it will go to once again top from network. The next packet will be accepted, it will be put into a frame, and that will be put in that will be given to the physical layer for the transmission. Once again it will wait for the event, and so on. At the receiver, here it has got two frames, first for accepting the actual data frame, and second for sending as an acknowledgement back to the sender. So once again only one event is possible, which is frame arrival. So in an infinite loop it checks wait for event. The first event possible is that a frame has just been arrived from the physical layer. So it goes to the physical layer and accept that frame into R, and the payload of that r.info will be transmitted to the network layer, which is nothing but the packet. At the same time, it also gives a frame, which is S, to the physical layer, which is acting as an acknowledgement frame to the sender, and this is the frame for which the sender was waiting at wait for event. So once that frame is received here, once again that will be going to the next thing, as we have seen previously. So this is the simplex stop and wait for a noisy channel. Here it solves the problem of flow control. Basically this is done by blocking the sender from sending the next frame until it receives the acknowledgement. But if the acknowledgement frame itself gets lost, the protocol will fail. There is no such implementation logic which will assume that it is always waiting for the acknowledgement frame, and then only the sender's for loop or the while loop will continue. So if the acknowledgement frame gets lost, it is always in an infinite waiting then. Here the error correction is also not implemented, and that is also one direction. That's not practical in short. So the third version is a positive acknowledgement with retransmission protocol. Here, this is once again an unidirectional. This allows for an this allows unidirectional flow, data flow, but the channel is now assumed to be unreliable. So here the max sequence is defined to be 1. We are checking only for one frame. So next is the event type, and these are the 3 events now possible. Previously there was only one event possible, the frame arrival. Here 3 events are now possible. First is the frame arrival, which is obvious, and second, at the receiver, when the frame is received, that may be received in error, so that there will be checksum error. So that event may be there, checksum error, or the frame itself was lost from sender to receiver or receiver to sender. It was not at all received before the timer elapsed, and that's how the third event possible is the timeout. So at the sender, we are defining a sequence number which is next underscore frame underscore to underscore send. Next frame to send, that's the sequence number. We can define any number here. So a frame is being defined, a packet is defined with buffer, and event type event, as we have seen previously. Here the next frame to send is defined to be 0, initialized. Now go and take a packet from network layer as usual, and in an infinite loop put the payload part into the frames info part and assign a sequence number to that frame, which is the next frame to send. Now at the first it will be assigned 0, and send this frame to the physical layer. At the same time, start timer for that s.sequence, this number, and also wait for event. What is the event possible? The frame arrival, there may be a checksum error, there may be a timeout. So if event is equal to frame arrival at the sender, from the physical layer accept the frame, check whether out of the accepted frames acknowledgement field has got the next frame to send value. If the acknowledgement part of that accepted frame is equal to next frame to send, that means the receiver has sent a frame back as part of acknowledgement, where the acknowledgement was given to the previously sent frame. That is the meaning, and that's how now it is sure that the receiver has received that frame, and that's how we are stopping the timer of the corresponding acknowledgement number of the frame. Now as the receiver has received the previous frame, I can that means the data link layer can go to the network layer and accept the next packet from network layer and buffer. And for the new frame which is to be formed out of this packet, increment the next frame to send, and then it goes with the same functionality on and on. At the receiver, once again, it is expecting some frame to be received, which is given the sequence number. It will be giving some sequence number, frame underscore expected. Once again, 2 frames are defined, one for the data frame and one for the acknowledgement, and event type is also defined. And receiver has also initialized that frame underscore expected with 0, the first value. And in an infinite loop, it is waiting for the some event. Once again, These are the two possibilities. Either a frame can arrive successfully, which is frame arrival, or it may arrive with some errors, that is checksum error. So if event is equal to frame arrival, that means a frame has arrived without any errors. So go to the physical layer, accept that frame into the variable r, and if r dot sequence is equal to frame expected, it was expecting a frame with the sequence number of 0. Why this is important? Because as we have seen that now the channel is erroneous, there may be a frame which is completely lost, and the next frame may arrive which rather the receiver is not expecting. That frame arrived has got a sequence number which is not equal to the frame or the sequence number which the receiver is expecting. And that's how, if the received frame sequence number is equal to the frame underscore expected, or the sequence number being expected, then only send that payload part of that frame to the network layer as the packet and increment frame expected. And if this thing is done, then s dot acknowledgement is equal to 1 minus frame expected. That means the acknowledgement number will always toggle between 0 and 1. If it is 0, 1 minus frame expected, that means 0, will make it 1. And if it is already made 1, it is 1 minus 1, that will make it 0. So that acknowledgement number is always toggling between 0 and 1. And to physical layer, it is now giving the acknowledgement of S. So S dot acknowledgement is now for whenever it was expecting 0. See, so frame expected was now here 0. So once it has successfully received, that has been given to the network layer, and now S dot acknowledgement is now made 1 minus frame expected, it is 0. And that's how to physical layer it is now giving that as 1. That means the previous frame has been received. That means a positive acknowledgement with a retransmission. So this is how we have seen the simplex protocols in 3 versions. We have seen why they are required, in what different contexts they will be used, and so on. Thank you.